All right. Good morning. Welcome back to Elements of Calculus 2. We are looking at Newton's method, and we have a problem here. It looks like e to the x minus 2x squared minus 5 is equal to 0, and we want to find where this thing actually crosses the axis. So Newton's method, again, you don't have to memorize this formula, but it's x n plus 1 equals x sub n minus f of x divided by f prime of x. Okay, and we're gonna guess a solution to this thing somewhere between 3 and 4, and we're going to go ahead and refine our guess. So we're going to work through this problem with, say, our first guess, and then we're just going to iterate this thing over and over and over and over again until we have a solution that doesn't really change where we actually want it to. We want it to be 3 decimal places. Once it stops changing and at 3 decimal places, we'll say that we're good and done. Okay, so you could pretty much pick any point between 3 and 4. I would generally pick something in the middle, and that's probably what we're going to do here. We're going to say, okay, somewhere between 3 and 4. Let's go ahead and pick 3.5. And the way these problems are worded is that you usually get an interval or you get like a place to guess to start your problem with, because you can't just say, well, anywhere you want. Like, no, you gotta, the closer you guess, the better off it's going to be. Um, and the idea is that we're tracking the derivative. So if we actually end up with like a problem that looks something like this, you get a function and you guess somewhere like here, you happen to actually guess the top. What happens is that when you're looking for like what your next number is going to be, it's going to use this derivative to kind of get what your next value is going to be. If you pick something that over on the other side, you're never going to intersect the function again, and it's just going to diverge, and you're never really going to get a good answer for this thing. So you have to kind of pick something that's fairly close, that's at least on the slope, to be able to figure out what's going to happen. And you're going to go ahead and ping pong up, and you're like, okay, we got a number that followed this function down, and then you're going to follow it back up, and then you're just going to keep getting a little bit better and better and better until you get closer and closer and closer to this little piece here. Okay, so let's go ahead and think about what happens with this. So we're going to need some functions. We have this one, and we're going to need a derivative. So let's go ahead and figure out what the derivative of my f of x actually is. So yay, we get to take another derivative. So we're going to say, okay, f prime of x is equal to e to the x minus, and we're just taking a derivative here. 4, 2 times 2 is 4, 4x. Derivative of a constant is 0, so here we go. Okay, so that's my derivative. And we're just going to use these two functions with our guesses to see how good we're going to get. Okay, I'm going to use a calculator here to kind of show you that I'm doing the problem correctly, but I'm not going to use anything that requires me to do graphing on the calculator. It's going to be effectively the same tools that you're allowed to have for your exams. So just because it's a fancier calculator, I'm not going to use any of the fancier functions for it. Okay, so here we go. We're going to say this is going to be 3.5 minus f of 3.5 divided by f prime of 3.5. And we're just going to figure out what's going to happen with that. So what is my f of 3.5? That's going to be e. Let me go ahead and go back to this is x to the 3.5. Okay, minus, and I'm just going back and looking at the original function, 2 times 3.5 squared. Okay, 2 times 3.5 squared minus 5. And then right underneath of it, we're going to go ahead and calculate f prime of 3.5. Okay, so that's going to be e to the 3.5 minus 4 times 3.5. And we're just going to go ahead and calculate these pieces now. All right, so let's see what we have here. We have clear, everything is cleared. Okay, we're good. So we're going to say second function ln 3.5. Don't forget to close your parentheses on these things. Minus 2 times 3.5 squared. How about we do 3.5 squared? 3.5 squared. 2 times 3.5 squared minus 5. We're just going to write this down. Enter. 3.61, and we'll carry this out for as long as we need to, but we'll say 3.61545. 3.61545. All right. Um, 3.615, 3.61545. Generally, you want to carry this out a couple more decimal places than you're looking for. Since I said we're going to do it to 3 decimal places, I'll do it to 5 decimal places, and we'll go ahead and do it that way. So I'll try to hold everything to 5 decimal places so that when we get to 3, we'll kind of know it's not changing. Okay, so second function, ln, to 3.5, 3.5, okay, minus 4 times 3.5, 3.5. So I forgot my parentheses. So let's go ahead and say insert and parenthesis. So e to the 3.5 minus 4 times 3.5. We're just going to do that. Okay. So we'll go ahead and do that and say equals. And I'm getting 19.11545. So it's 19.11545. Okay, I believe that's what I have here. All right. So let's go ahead and put this in our algorithm. We're going to say this is going to be 3.5 minus, and then we're going to have 3.61545 divided by 19.11545. All right, so we just go through and do that. So let's see here. We have 3.5 here minus 3.6 1545 divided by, so let's go with divided by, and then we have 19.11545. Okay, and we're going to say equals. So this takes care of the fact that I started off with a 3.6 or 3.5. So we have all of that. So this is equaling to 3.31 equals 3.31. If you have a decent calculator, I would put this in storage, put this number in storage so you can keep all of the decimal places and you can kind of do it that way. But we're just going to go with the 5 decimal places that I said, 3.31086. 086. And that's going to be my new number that I'm going to do everything with. Okay. So my next value, we're going to say I need to know what f of 3.31086 is equal to. All right. And then we're going to say f prime of 3.31086 86 is equal to. So we're going to go ahead and calculate that out. And this is all this is doing. We're just putting it into the function over and over and over again and getting what this result's going to be. So let's say we have e to the 3.31086 minus, and then we had I believe I want the original function, minus 2, 3.31086 squared, and I believe there was a minus 5 at the end there. Yep, it sure was. And then what we're going to do is we're going to say this is e to the 3.31086, and my f prime, okay, goes to minus 4x. So minus 4 times 3.31086, and we're just going to go through and calculate these two values here. So let's go ahead and do that. So we have second function ln, okay. Let's see, what is this? It was 3.31086 and parentheses, okay, minus, let's see, 2 times 3.31. Oh, that's not what I want. 3 point, okay, 3.31086. Okay, I suspect all of you are going to have a bit of an easier time with this than I am, just because manipulating a calculator on a computer is not really a lot of fun. But minus the 5, just doing it like with a real calculator is going to be a lot easier. Okay. So we have the function, we have 2 times this thing squared minus 5 equals, because it's so important that this has to happen, we have to make sure we're pretty accurate with all of our numbers here. So we're going to see 0.485, 0.4850, Okay, 0.4850. We're going to go with, okay, where are we going with what? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to rate that 4.850. We're going to say 99 because we're going to, again, we're going to keep this to the 5 decimal places. Okay. And then we'll go ahead and calculate the other one. Okay. So this is going to be second function ln. And then what do we have here? 3.3, 3 point. No, I want, good Lord, uh, decimal place. Come on, dude. Okay. 3.31. There we are. 31, 086 and parentheses. Okay, and we were looking at, I think, -4, right? That's what we are up here. Yep. Let's go ahead and get rid of this. Oh, there it is. Never mind. I'm doing this. So minus four times, and we'll say 3 point. Make sure I can get that decimal place this time. 31086. All right. Equals. And then we have 14 point. Okay. Oh, let me get back to my eraser. Where's my pen? Okay. 14.1652. All right. 1.165. 14.1652. We'll say 25. Okay. Here's one of the things that I want you to kind of pay attention to is notice that the numerator and the denominator, like this is going to, we're going to take this numerator, divide it the 0.45, and we're going to divide it by 14. This is like zero point 0.1 divided by 10. We're going to be changing the 100th place. So it's going to keep moving down for like where we should actually be changing things. So this one might change in a tens place because this 100th place is just a 1, but it should slowly start moving down as we go through this process. It should change further and further and further down on the decimal chain here. So eventually you'll say like, oh wait, the first three numbers aren't changing anymore because the numbers that we're going to be multiplying or adding by are going to be very, very small. Okay, so let's go ahead. And what we had to do was to say 3.31086 minus 0.485099 divided by 14.16525 and then equals. So we can go ahead and type that in here. Okay. So we had, what was this? This was 3 point, here we go. 31086 minus, and then what do we have next? We had point. So we have is 0.485099 divided by, so we'll go divided by, well, just the keyboard, 14.16525. All right. And it will say equals. And then, like I said, it's probably going to change a little bit because it was only a 1 there. So we end up with 3.27, right? Let's see. We had 3.27661. 3.27661. Okay. Looking at what we had before, we had 3.31. Now we have 3.27. So these changed by a little bit, but not enough. Like if they still change by too much, we have to recycle this once more. So one more time around the ride here. So f of 3.27, right? 3.27, 661, which is going to be e to the 3.27, 661 minus twice 3.27, 661 squared minus 5. And we could say something like this is f prime of 3.27661. You don't have to write out all of these steps when you're doing it. I find that if you get lost somewhere in the middle, it helps to leave yourself a trail of breadcrumbs so you can kind of figure out if you have a slightly different way. But it is nice to like tell the person who's reading, that would be me, your work, what you're doing at what time. Okay. So this is going to be 3 point or e to the 3.31 6 3, 3 point. I was reading the previous line there. 3 point, okay, 27661. And we were going to say minus 4 times 3.27661. Okay, we'll try to make our parentheses look like parentheses rather than ones. All right, so that's what we have for that. Now we have to go through and calculate what these values are going to be. Again, if you use the storage key, I would highly recommend that you can just like recall it and go ahead and plug that function into your, or plug that number into your function, and it's not going to be quite so tedious as what I'm showing here. So we have e to the, and it'll be 3.27661 and parentheses. Don't forget to do that. Minus 2 times 3.27661. And I believe that was squared. Yeah, it sure was. Let's go ahead and square it. And then minus 5. All right. So we'll go ahead and double check, make sure that we're using the right formula. That looks pretty good. Enter. And I got 0.01334. Okay. So 0 point. Let's go ahead and check, double check my numbers. 13487. 1348. I'm going to check that last digit. 87. Yeah, because my rounding is going to be a 1 there, so we can go ahead and leave it like that. 1, 2, 3, 4, 5. Beautiful. All right, and now we're just going to calculate the value for the f prime at that point. So second function ln. Oops, sorry, don't do that. Second function ln. Okay, and I want, here we go. 3 point. Nope, I just want 3 point. Ah, shoot. Here we go. Nope, still can't type. Fine. 3 point. There it is. 3.27661 and my parentheses. Okay, minus, and we're going to say 4 times, 3.27, 661. All right, and then go ahead and say enter for that. Make sure my parentheses are sorted. So we have 13 point, and we're going to say 13.37, 13.37, 939. All right. So let's go ahead and again, we're doing this one more time. So we have 3.27661 minus, and then we're going to take our function value, 0.13487 divided by 13 rather, 13.379319. Okay, just going and dragging these numbers over and making sure that this is all working out correctly. All right, so let's go ahead and see what we ended up with. So we have 3.27661 minus the quotient here. You don't need to put in the leading zero into the calculator, it knows, but I did anyway. 13, and what do we have here? 13, 47. So we have 487, 4, 13, good Lord. 13, we have 487 here, very good. And it will say divided by, this is 13, 13.379379319. Okay, and we'll go ahead and say what that equals. So we'll just enter it. Voila. And what did I end up with? I ended up with 3.266. Okay, so you can see it's not changing quite as much now. So 3.26653. 26653. And again, remember, we only want to go to the third decimal place. So once it stops changing there, we're not going to worry about it after that. Okay, and you'll see, if you carry this out far enough, like it will stop changing. So we got 3.27 for last time. We got 3.26 this time. So one more time around the merry-go-round here. All right. So we have to go through and calculate this thing out one more time. And I promise you it doesn't take nearly as long doing this with your hands and you're watching me do it. So we want f of, okay, we want 3 point, so 3.26653, and we're going to say this is e to the 3.26653. 1, 2, 3, 4, 5. We're still going with that. Minus twice 3.266. Don't use the wrong numbers. That will screw up our calculation and we'll never get to an answer. 3.26653 squared minus 5, and we'll sort that out. And then we've got f prime of 3.26653, 1, 2, 3, 4, 5, okay, which is equal to e to the 3.26653 minus 4 times 3.2 rather. Again, use the right numbers. That makes it easier. All right. So we have 3.26653, and we'll see what that equals. Okay, so let's go ahead and plug those two things in the calculator, which I know has got to be delightful video watching. But there we go. All right. So we'll say this is second function ln. So we have, let's see here, 3.26653 and my parentheses minus, we have, what do we have? We have 2 times, there we go, 2 times, I want 3.26653 squared, okay? And then we're going to say minus 5. So let's go with that. Just minus 5. All right. So like I said, again, you're going to see like this is a much easier thing for you to deal with on the calculator. So look at this. We get a negative. So negative 0.12, negative 0.12, and then we'll go through and write down the rest of the decimals. 0.024. Okay, 1, 2, 3, 4, 5. And then we'll go ahead and calculate our f prime value. That'll be our denominator. So this is going to be second function ln. Second function ln. There you are. We have e to the, and we have 3.26653. Okay, and parentheses. Minus 4 times, where's my times button? It's way over there. 4 times 3.26653. All right. So let's go ahead and do that. Double checking. We got 13 point. So 13.1541. 13.154. And that, oh, we're going to go with 5 decimal places. 1, 2, 3, 4, 5. Okay, 1540. Okay, we try to be consistent with our numbers here. And then this last decimal, this 7 and the 6 decimal place is going to round that to an 8 there. All right, and now what we have to do is we have to figure out this whole thing again. So 3.26653 minus, and we're going to have negative 0.12024. 12024 over 13.15408. Notice we have a negative times a negative here, so it's actually going to be a plus. We could simplify this a little bit. So we're going to plug it into the calculator. 3.26653 plus 0.12024 divided by 13.15408 and figure out what that equals. So let's go ahead and do that calculation. So this is 3.26653 plus, and then we're going to say 0.12024 divided by, where's my divide key? Divided by 13.15408. Okay, so I took care of that negative sign algebraically, so I wouldn't have to worry about trying to type in a calculator with like a negative thing. So that's how that works. Enter. And look at this. I got 3.27. So this was back up to 3.27. Okay, so look how it's changed. Like the 3.2 stayed. Okay, the 3.2 stayed, and now things that changed. 3.27, 5.6, we'll say 0.567, 3.27, 5.67. Okay, so notice like the 3.2 change, the 3.2 stayed, 3.2 was the same. Okay, and it's going to start percolating down. So like the next down things change and it'll go forth that way. So once you see like, hey, we're starting to get some convergence on this, like the first two numbers have stayed the same, you know, you're starting to get to the end on this thing. All right. If you end up with like, it's wildly changing at this point, what you think is like, okay, we may have picked the wrong starting point, so it doesn't really, that slope doesn't go down to that zero. So if you end up saying like, oh, this is going further and further and further abroad, you might want to start from the beginning and say, let me pick a better starting point than the guess that I had, because you may have accidentally guessed like a peak, or you may have actually, if you're looking for like where it crosses and you crossed over here, it's going to take a long time for Newton's method to find this space because the function is just going to keep going up and it's not going to quite do this for you. And it's going to take a long, long time to converge. You really want to be on the right side of the hill in order to figure out where this thing is going to go. All right. So if it's getting bigger and bigger and bigger, reset and make sure that you've done a better job guessing up a number. You might want to try like we're going to use intermediate. You might want to use intermediate value theorem, which means if you pick a point, some arbitrary point, and pick another arbitrary point and find a zero, like one's positive and one's negative, and like, aha, there's a zero between these 2 points. Let's pick one of these 2 points, or maybe even halfway, but you want to pick a point in this interval at that point. This work has been done for us when they set the problem up for us. Okay, you're not responsible for doing this on an exam or in your homework problems, but if you ever go out and have to do this problem for real, where they don't hand this to you, you might want to just plot a couple of points and then pay attention to where does it change to positive to negative. Like that might be where I want to start looking. All right, so here we have 3.27567. So we have to go through this whole thing, yeah, one more time. Okay, so we're going to say e to the 3.27567 minus, and this was 3.27567 squared minus, I believe it was 5. Yep, it sure was. And then our f prime, all right, is going to be, so this was f of x, and we have f prime of x, and this was e to the 3.27 517 minus 4 times 3.3, not 2. Come here. All right, here 3.4 times 3.27567, and then figure out what this equals. Okay, and I'm sorry that these problems last a long time, but again, when you're doing this by hand, it's not quite as long as what I'm doing because, yeah, there's things that happened. All right, clear. All right, so here we have second function ln. Here we go. 3 point. Oh, how about we go 3 point? Lord. 3 point. Okay. 2727 567 and parentheses. Okay. Minus 2. 2 times 3.2727 567, and we're going to square that, and then minus 5. Okay. And we'll figure out what that is. And see, look at this. We have 9.2048 times 10 to the negative fourth. So this is getting to be kind of a small number here. So we have 9 point, what do we have here? We have 9.2048, 2048. Again, we were going to 5 decimal places. So 1, 2, 3, 4, 5, 2, 4, 8, 0 times 10 to the negative fourth power. All right, and we'll go ahead and calculate what we need for the f prime of x. So we're going to say this is second function ln. Okay, 3.27567. Okay. And my parentheses, minus 4 times 3.27567. So we're just going to go ahead and calculate that. That is equal to 13 point. So 13.3583. 13 point, there we go, excuse me. 13.3583. 3583. All right. Okay. Now again, we have to go ahead and say, okay, we have 3.27567 minus, and here is 9.2048 times 10 to the negative fourth power. That's going to be kind of a small number, divided by my 13.5858. 13 point, oh, let me get the right number here. Otherwise, it'll start messing everything up. Okay, and you can see that we're getting a small number divided by a bigger number. And again, it should be a much smaller number. So we should only be changing things in like the next to the last decimal place again now. 583, and then say equals. Okay, let's go ahead and calculate this little step here. So we have 13.27567, 27567 minus, and this is going to be 9. How about 9? 9 points. Where's my point? Point 2048. And I've got to say this EE button here, second function EE, minus 4. Use the right minus sign, otherwise it'll mess up because it thinks don't do subtraction, use the negative sign. Divided by, and then we have 13 points. 3583. 35. Oh, it is 35. What was this? I think there was a 183 here. Okay. I think this was a 183 here. Oh, we'll go with this. Okay. When I watch this back, I'll be screaming at it like, no, it's supposed to be a different number. Your handwriting is terrible. Okay, equals. And then what do we end up with? Oh, that's not right. Oh, yes. Yes, it is. We have, what did we end up with? No, it isn't. That's not right because that came out to be 13. That's way different than a 3. Okay, so what did I mess up with this one? Oh, then what I messed up? I didn't type in the right number when I started. Oh, I'm so sorry about that. 3.27567. There you go. Minus, and then we're going to have 9.2048. Second function, EE, negative 4, divided by, all right. And then we have 13.35183, all right. And we'll go plug that in. And now I got, that looks a lot better. Look at that. It's 3.275, 3.275. Okay, 3.275, 6, 0. And I'm looking at what's going on here, right? We have 3.27567, 3.2756. What do we get with my last number here? 2.560. So when I'm saying like do this to the like third decimal place, we could see it's not changing in our third decimal place anymore. At that point, we could say that I think this is 3.275 or 3.276 to round it. And I'd say that's my solution for when this function equals 0. And that way, you've got a good answer for this thing. Now, let's see, can I do that? No, I can't do that. So we'll go ahead and call that there and say, this is how you do Newton's method. Again, don't be intimidated by the fact it takes me a painfully long time to do this. It's glacial, where you are going to be a much faster person at doing this because you actually get to manipulate the calculator with your fingers. And you're going to have to jot down some numbers off to the side, but it's not going to take nearly as long as the situation that I've got sitting here. Okay, like I'm just faster with this on paper than I am with doing calculator. You're also probably not nearly as vision impaired as I am anymore. So we'll go with that. All right, so I'm going to say thank you very much for watching the video. Good luck with doing Newton's method. It's not nearly as it's tedious. I won't lie to you on that one. It is tedious, but if you've got nothing, you're sitting on an airplane and you've got nothing to do for 3 hours, uh, this is a really good way to pass the time. All right, thank you very much for watching, and good luck.